What's going on, folks? Here with another video. Trying to do as many labs as I can. Had a pretty long day at work today, so I'm a little tired. So probably after this, go do some reading on some theory stuff. But at least wanted to try to work my way through the rest of the lab. As you can see, look at my contents. I got a pretty long way to go. My next topic is going to be for L3 VPN. These are all the topics I have left, and then I have my advanced technology labs for the L2 VPN services, and then MPLS and then the services, and then the part that I really can't wait for, which is the assessment labs. So I'm pretty exciting about that. But yep. So we're gonna go ahead and start first here on the L3 VPN with Ospf Domain Id. Now, if you watched my last video, I kind of went over the domain ID when I was talking about the sham link configuration. I think this kind of came in a little backwards. I think they should have did domain ID first, but that's just my personal opinion. But ideally, what the domain ID is a extended community that is sent in the VPN v4 update once OSPF is redistributed into VPN v4 BGP. And the PEs use this as a way to, once BGP gets redistributed back into OSPF, for it to advertise the correct LSA type down to the CE. In this case, the rule is that if the domain IDs do not match, the route in the routing table for the CE will be an external Type 5 LSA that gets sent out. If the domain IDs do match, what you would end up with is an inter-area route, an OIA route in the routing table. And then the sham link, as we showed in the previous video, is a way to extend the flooding domain, which would be your Type 1 router LSAs that would get sent across to be able to flood out to be an intra-area route, which is just this regular O route in the OSPF routing table. So that's the different uses of what you can do with domain ID. It's another way for manipulating OSPF path selection. So in this particular case, we're just going to run through this configuration. A lot of it is repetitive from the last one, but I figured what I want to do is start from scratch on each lab, just so you guys can see me work my way through it, and I make mistakes as I go all the time. So you got to constantly be understanding what's happening in the topology, what's not happening in topology. I mean, this is what's going to make or break you in the CCIE lab. So um, I'll keep my mistakes in here on purpose because I want you guys to understand my thought process and the things that I think about whenever I'm trying to figure something out. A lot of it, I'm pretty sure you guys are on the other side of the screen yelling at me what the obvious is because you guys are probably smarter than I am. Can't knock that sometimes, but just wanted to guys give you what the raw look like of how I study. And this is actually a study session for me. This isn't just a video thing. I'm actually studying for my CCIE service provider, and so this is just me working through it. So let's go ahead and get started. MPLS L through VPN OSPF domain IDs. Now, let's go ahead and just read through the task here, and as we go through the task, we'll go ahead and start configuring all the different tasks as we go. So we're gonna configure. Well, first let's look at our topology. The notes say that we're going to use the L3 VPN backdoor links topology, which is this one here. And let's go ahead and just identify our configuration. Based off of the sham link, I know what the topology is going to end up working as. So we have R2 and XR1, which is our PE routers. R3, 6, 4, and 5 is our actual core routers, our P core routers. And R1 and XR2 is our CE routers in this particular instance. So let's go ahead and read through the configuration steps and then get started. So the first step is create a new loopback on R1 with an IP address of 10.1.1.1. Okay, and then we're going to create a new loopback on new black interface on XR2 with with the IP address of 10.20.20.20.20. Easy. Configure a VRF on XR2 and XR1, which is our PE routers with that VPN and that route distinguisher and route target attributes, and assign the interfaces to the correct VRF. Pretty simple. And on OSPF routing, we're going to configure it using process ID 100. We're going to configure area 1 or area 0 between XR2 and R1, area 0 between XR1 and XR2, and then we're going to enable area 120 between XR1 and XR2. All right. And then we're going to advertise that loopback of 0 of XR1 into area 1. We're going to advertise the loopback of 0 of XR2 into area 20. We're going to redistribute the loopback 1 networks of XR1 into OSPF. So we're going to redistribute the connected interface. And then we're going to modify the link between XR1 and XR2 to have a cost of 100. And then we're going to modify the domain ID on XR1 and R2 with the domain ID of this hex value here. And we're going to configure BGP on R2 and XR1 using BGP AS100. We're going to use the VPN v4 address family pairings using loopback 0 as their update source, and we're going to redistribute between the VRF aware processes, the VRF aware OSPF process, and the IBGP. And then for validation, we're going to say XR1 and R1 and XR2 should have reachability to all of each other's networks. Traffic between the loopback 0 networks of XR1 and XR2 should prefer the use of the MPLS network, and traffic between loopback 1 should prefer the backdoor link. And if either XR1 and XR2 loses connectivity to the MPLS cloud or the backdoor link, traffic should automatically be rerouted accordingly. Okay, so pretty simple. Pretty straightforward. I'm not going to say simple. This is going to be a pretty long configuration, so I might break this video up, but if not, hope you guys can truck along with me. So let's go ahead and get started here. So we're going to need to create the two new loopback addresses on R1 and XR2. So we got that up. So on their interfaces, it needs to be 10.1.1.1 and 10.20.20.20. So let's go ahead and log into R1 to do that. Interface loopback 1, IP address 10.1.1.1. Too many ones. Okay, so that's good. And then XR2, we need to do the same thing. Okay, perfect. So the first two steps are completed. And then we're going to configure a VRF in R2 and XR1 with the VPN A. So that's pretty easy. Just go ahead and do that piece now. That's good. So I'm just going to quickly go through this because we kind of seen this configuration in the last lab before. So we're going to VRF forwarding VPN A. That's good. Same thing on XR1. Alright. I have to remove this first. Okay, perfect. So that piece is done. We're kind of missing something on XR1. I like to just get this out of the way. So we already know the BGP process is going to be 100, and we're just going to do VPN, and then we're going to do route distinguisher. Okay, good. So that's good. Alright, so we're going to do some OSPF routing. So we're going to use a process ID of 100, and we're going to enable OSPF area 0 between R1 and R2. So if we look back on the diagram, we're going to enable it now between R1 and R2. Okay. And then same thing with R2. So that should be done. OSPF should come up here shortly. And then we need to do the same thing between XR1 and XR2. Okay, why is it not? Oh, you know what? Unshut that. And I think last time, showing what the interface brief, his interface wasn't up either. Just to save myself some headache. Okay, looks good. Okay, looks good. Okay, good. So neighborship is coming up here. So same thing with XR2 and XR1, which is this link between these two here. So XR2, just RE0, base gig. Actually, you know what? Did it say to use? Yes, it's area 0. So 1920. Then on XR1, so that's coming up here. Should be popping up there shortly. Yeah, it's going through the exchanging process now. And then between R1 and XR2, we're going to use area 120. So on this link here, R1 and XR2, we're going to do area 120. So R1, that's good. That should be good. That neighbor should come up here shortly. So that's coming up here now. This guy's neighbor should be up already. So they're both coming up there. So that's done, and we want to advertise loopback 0 into OSPF area 1 for R1. So loopback area 1. Next R2, you're going to put him in area 20. So let's see, 100, area 20, interface loopback 0. That's good. And then we're going to redistribute networks of R2, of R1 and R2 in the OSPF. So what that means is we're going to, so router OSPF 100. So what we can do is this. I'm going to go ahead and create a route map to do this, so I can just make sure that I'm redistributing only the router 2, only the loopback address. So I'm going to do an IP prefix list R1 permit 10.1.1.1/32 and then we're going to create a route map RD OSPF. And we're going to do permit 100, and then we're going to match IP address prefix list R1. Alright, so router OSPF 100, redistribute connected route map RD OSPF. So to verify that's working, you should be able to look in this guy, show IP route VRF VPN A, and I should see an external route coming in from there. So that's good. And now on XR2, we got to do the same thing. So I'm going to go router OSPF 100, and then address family IPv4 unicast. Oh, you know what? Did I add show run loopback 1? Show run interface loopback 1. Didn't do that. So let me go back and add this interface to the VRF, because that should be a part of the VRF. So we're going to take this off. And then we're going to VRF VPN A. And then re-add the IP address. So router OSPF 100, address family IPv4 unicast. We're going to redistribute connected route policy. We're going to create an RPL policy. Let's create a route policy real quick as well. So we're going to do route policy. We're going to do RD OSPF, and then we're going to do if destination, and we're going to do a prefix, inline prefix set. So we're going to do 10.20.20.20/32, then pass, and if, and then router OSPF 100, address family IPv4 unicast, redistribute connected route policy. We're going to call this RD OSPF, and then commit. So let's check XR1 and make sure that route is in the routing table now. And it is not. Let's see. Why is my loopback down? That is super odd. Never seen that before. Now I'm having some weird stuff going on here. Okay. Now that is weird. IP address it told me to give it, right? 10.20.20.20/32. That is weird as heck. Let's do another loopback. Always have these weird things happen to me. That is super odd. What's keeping this from happening? Alright. Oh, that's what I didn't do. No, that's right. I'm such an idiot. I'm on the wrong router. See? Stuff like this, man. Trying to do this thing for you guys, and I make mistakes all the time. This doesn't go into a VRF. Oh, excuse me. Let's see. I don't know why I thought that needed. I'm tripping, guys. Told you I'm tired. Should not be doing this on this brain status, but I'm able to catch my mistakes. Just do a no interface loopback 2, interface loopback 1, no VRF VPN A, no IPv4 address. So, back 1, 4 address 10 dot. Okay. Gotta unshut it. So now he should be receiving that route in his routing table, which he is. Yep, perfect. Hush. Stupid mistakes like that cost time, guys. Big time. Okay, so we did that. We redistributed it loopback 1 of R1 and R2 into OSPF. And then we're going to modify the link between R1 and XR2 to have an OSPF cost of 100. So that's easy. That's done. And then XR2. Take that. Plus 100. Good. So that's done. And then, so let's look at what the domain, what the OSPF database looks like right now. So from router 2's perspective, let's do a show IP route. Now, as you notice that the route that is coming from router 20, which is XR2, to get to router 20's loopback 1, we're actually going over this link that we have that is, let's pull up the diagram, that is right here. And the reason being is that when I look at the type 5 LSA, it's going to say the originating router should be referencing router 2's type 1 LSA. So let's look at this. Show IP database, show IP OSPF database. And then we'll do external, and we'll do it for 10.20.20. 10.20.20. So it's going to say the link state ID is 10.20.20.20. The advertising router is router 20's router ID. And then the so when it goes and does the route recursion process to actually verify where it's at, it's going to say that's 0. Oh, because here, if we look at his this guy's router link state, we should see as a part of its connected interfaces. Ospf Database. Actually, we need to look at the router ID. Ah, okay. Because he's a part of Area 120, it's going to be here. So I need to look at it for Area 120. Because I'm like, where am I not getting my router ID? Ospf Database router. Bam. So when I look at that, we're going to see that they have one transit address, which is 10.1.20.2, which means that he is going to actually be going out of that interface for forwarding. So when we look at the type 5 LSA, the originator of it is going to be router 20, and his forwarding address is all zeros, which indicates that he is the forwarding interface. He's going to be the forwarder. In that case, when you look at the type 1 LSA from router 2 that's coming out of area 20, he's saying that I'm going to go through my transit link, which is 10.1.20, which references this link here. So I'm good to go there. And let's look at it from XR2 standpoint. Show OSPF database or show route, and we're going to see the same thing here, 10.1.1.1. So show OSPF database external, and then 10.1.1.1. Now the advertising router is 10.1.1.1, and the link state ID is 10.1.1.1. Same thing, you're seeing the forwarding address here. So what we need to do is for area, which area is this a part of? For area should be 120. That's not showing me that, but if I look at the show OSPF database, I'm going to be coming that from the 120 database here. So what I want to do is look at that 10.1. Oh, okay. So I am getting some false positives here. This guy is, and I'm pretty sure this has to do with the way iOS XR does not set the domain ID. So 10.1.1.1. That's the summary. It's the net. Oh no, here it is. Okay, here it is. I'm tripping. So we want to look at the router. I just didn't see the. So same thing. He's gonna say he's himself as the forwarding address, which means it's gonna be his transit link, which would be this 10.1.20.1 as the DR interface. But the designated router address is gonna be router 20's IP address. He was the DR in this case, but the transit link that they're gonna be going through is over that link there. So based off of best path selection from the area, we're routing within the area to get to the area border router, which in this case is going to be XR2 technically because of the interfaces being in different areas between this guy and this guy. So let's go on and finish up with the rest of the configuration. Oh, I'm sorry, I didn't say this guy and this guy, but between these guys being in area 120, he is actually going to be the area border router where he's going to be routing to that edge, the ASBR essentially, or the ABR, and at that point gets at router 1. So let's look back at the rest of the task. So we already did this, and we need to configure domain ID on R2 and XR1 for the VRF aware process with type 5 and being the domain ID of this. So that's pretty straightforward. So on R2, what we're going to need to do is go under router OSPF 100, and then domain ID, and then we're going to do type 005, and then the value being in hex. I always actually just put the hex number there. So we're going to take that, put that in there, perfect. And then same thing under XR1. We're going to go here, router Ospf 100, VRF, VPN A, and then I believe this should use the exact same command. Yep, same command, then commit. So now let's see what changed in the Ospf database. Show IP route. Oh, you know what? Nothing's going to change yet because we still got to do the VPN v4 session on the BGP. So all the Ospf configuration is completed. Now let's go ahead and get the BGP VPN v4 sessions up between R2 and XR1. So I'm going to do router BGP, and then we're going to know BGP default address family, IPv4 unicast, and then we're going to do a neighbor 19.19.19.19 remote AS 100, date source loopback 0, address family VPN v4 unicast neighbor 19.19.19.19. Activate. Perfect. So XR1, router BGP 100, address family VPN v4, VPN v4 unicast, and then neighbor 2.2. Remote AS 100. Update source loopback 0. Address family VPN v4 unicast. And then commit. And then that should bring up our VPN v4 sessions. And then we're going to need to redistribute between the BGP and VRF aware processes. So let's go ahead and do that now. So VRF VPN A. And then we'll do address family IPv4 unicast. They're going to redistribute Ospf 100. And then vice versa. Router Ospf 100. VRF VPN A. Redistribute BGP 100. That's good. Same thing here. Distribute BGP 100 subnets, and then under BGP, before VRF VPN A, redistribute Ospf 100. Perfect. So now, if I look at the routing table, now let's verify that that's all good. So look at the verification. So R1 and XR2 should have reachability to each other's loopbacks, so each other's networks. So I should be able to ping 20.20.20. Source loopback 1, source loopback 0. That's good. So we got bidirectional on XR1 and XR2. So route traffic between loopback 0 of R1 should prefer to use the MPLS network. Let's see that. So we'll do a trace route to 20.20.20.20 source loopback 0. As it does, prefer to use MPLS network, and then traffic between loopback 1 should prefer to use the backdoor link. So let's do that. Let's do a trace route. 10.20.20.20 source loopback 1. And as you can see, it's going over that link between R1 and XR2. And the reason being, show IP OSPF database, is that because the domain ID for the routes that were coming as an external from before are now showing as intra-area routes, which would have been the loopback addresses. So now those routes aren't not being showed as intra-area routes. They're actually looked at as show IP route, and we look at it, it should be an intra-area route going towards the MPLS network. That's why going to 20.20.20.20 is going over the MPLS network. This link here, 10.20.20.20, because it's a completely different area ID and it's actually an external redistribution going into the routing process from each prospective PE or CE router. Um, it's going to be going based off of the route. It's going to route to the nearest edge or the ABR, which is going to be based off of its type 1 LSA, which would be going to router 20 in this case. That's why it's going over that gig.1.20 interface here. And when I say that, let me show you what I mean. So it's just show IP Ospf Database external here. It's going to say the advertising router is 20.20.20, which forwarding address is 0.0.0, which if we look at this guy's show IP OSPF database router LSA, it's still going to show it going through that link between itself and router 20. Now, if I do the same thing on this guy and look at the summary route for 20.20.20, show OSPF, show IP OSPF database summary. Okay, so which one has the routing bit set? We gotta look for the route with the routing bit set, routing bit set, routing bit set. Where is my routing bit set? Oh, okay, so where is, we got the downward. Oh, because it's showing it for different areas. So what we want to look at is the one for area 0. Where is my area 0? Oh, here it is. Oh, because, okay, so here it is here. So when we look at the link state, it's going to say the advertising router is going to be this guy, and because area 0 is the backbone router, he's actually going to prefer area 0 to route over for the intra-area routes, because by default with the hierarchical design of OSPF, intra-area routes are going to have to traverse area 0 for flooding. Area 1 and the area 120 won't work, because in order for that to flood over, you're going to actually need to have a virtual link, because of the discontiguous areas on those in particular interfaces. So that's why the routing decision is happening the way it is. But that was pretty much the configuration for the domain ID. All we did was modify it on the PEs, so that way the routes that are learned from the VPN v4, which I'll show you here. So show BGP all, and then if I do a show BGP all or show BGP VPN v4 unicast VRF or unicast all, and I take the IP address of 20.20.20.20, which I'm running from router 19, we can see that domain ID that's setting in the extended community for OSPF. That's being set there. So when you're looking at that, you understand what's actually happening on why the route is being sent as an intra-area route from router 2 down to router 1. And because of the hierarchical design of the intra-area communication having to traverse the backbone area of area 0, from router 1's perspective, that is the reason why he's selecting the intra-area route to traverse over to router 2 to get over to router 20's loopback 0 address, for that particular purpose. Um, so that is OSPF domain ID manipulation. We're going to go ahead and put a check there and then call this a night. I'm pretty tired. Did a lot of things today. Probably do one more reading of another chapter, but for the most part, labbing is completed. Would have loved to done some more, but yeah, my brain's pretty fried right now. So, all right, guys, I will see you guys in the next video. Peace.